The Defense Advanced Research Projects Agency, or DARPA, has had a long history of funding breakthrough AI research. DARPA's Grand Challenge initiated the research field that rendered self-driving cars, while its Personal Assistant That Learns program was responsible for the technology that led to Apple's Siri. My guest today is Dr. Kathleen Fisher, the director of DARPA's Information Innovation Office. In this episode, you will hear about DARPA's history of generating groundbreaking research and development for 65 years. You will also hear about the recent AI Forward initiative that explores new directions for AI research that will result in trustworthy systems for national security missions. This is the Gradient Podcast, and I am your host, Daniel Bashir. If you've been listening to the podcast for a while, or if you are new, you may or may not know that The Gradient is a project run by a few engineers and grad students. The podcast is, at the moment, a one-person effort. If you like what we're doing, it would mean a lot to us and to me if you'd consider supporting us by either writing a review wherever you're listening to this podcast or upgrading to a paid subscription on Substack. But now, without further ado, Kathleen Fisher. Kathleen, I usually start these sessions a bit biographical. So you are currently the director of DARPA's Information Innovation Office. I'd love to hear a little bit about your background and how you ended up at DARPA.
Sure. So I started out as a grad student at Stanford. My background is actually in programming languages, but I had a couple of friends who were doing AI kinds of work, and that was in one of the AI winters. So one of my friends was doing work in neural nets and trying to get it to recognize handwritten digits and barely managing to get it to work. It did work, and they got it adopted by the post office. But that was like a monumental achievement, which I think kind of shows one of the common features of computer science is that it's not just the technology, but the context of the technology that's important. And neural networks in the early 90s were premature for their time, right? We need much more computation and much more data. Another one of my friends was working on expert systems, which is trying to get kind of what at DARPA we call symbolic AI to be useful for something, because it wasn't doing what we wanted for AI capabilities. When I finished my PhD, I went to work for AT&T Labs. They were hiring they had a vision for a programming language group, and I was going to be the theorist for the programming language group. But after they hired me, but before I actually showed up, that vision kind of fell apart. And then it was quickly apparent that you don't actually need a theorist for a group that you don't have. So I changed my research focus at that point to work on domain-specific programming languages and helped some statisticians build a programming language along with another programming language researcher, build a domain-specific language for building customer profiles, individual customer profiles to work on automatic fraud. They wanted it for fraud detection, but so far they'd only been able to do it for marketing kinds of applications. So back at that time frame in the early 90s, building up something that would process hundreds of millions of call detail records every day to build profiles of individual customers was really pushing what was possible at that kind of scale. So we built the language called Hancock that was published in KDD, and with the combination of statistical capabilities and system capabilities, was in fact able to do fraud applications. So that was kind of early days of large-scale data processing. From there, when my daughter went to college, I changed and became a professor at Tufts, and then detoured through DARPA. And at DARPA, I started the probabilistic programming for machine language program, the PAML program. And that was largely motivated by looking at machine learning applications that were running the sort of same algorithm over and over again, Monte Carlo kind of algorithms, with my background in programming languages, where if you're running the same algorithm over and over and over again, that's what compilers are really good at, figuring out how to do small optimizations and making a big performance can make a big performance optimization. So that was the impetus for that program. And then I became a professor at Tufts and department chair. And then DARPA asked me to come back to DARPA to be the office lead for the Information Innovation Office, which has been funding and working on AI for a really long time. Once I started here at DARPA, they asked to put together an analytic framework for what's the future of AI. right before ChatGPT came out, or maybe a year before ChatGPT came out. So I started doing a deep dive in AI right then.
So, one thing I'm noticing, and I'd love to ask you about before we dive more into DARPA and its history, is there have historically, and I think now, been a lot of really interesting intersections between programming languages and artificial intelligence. I got the chance to highlight a couple of these with Talia Ringer on a recent episode, ideas like proof repair with large language models. And I'm curious if you have any retrospective just on how this intersection of interests has evolved over the time that you've been involved in these communities.
Yeah, so I think that programming languages cares a lot about representation and about the logic side of AI. So, at DARPA, we think about kind of three waves of AI. So, the first wave being symbolic AI, kind of grounded in logical representation. The second wave being statistical AI, which is machine learning kind of styles of AI. And then DARPA, maybe 10 years ago, talked about third wave AI, sometimes called contextual AI, with the goal of kind of trying to merge the strengths of both the symbolic and the statistical AI to get the flexibility of statistical AI with some of the reasoning that you could get and the guarantees you could get out of first wave AI. A lot of programming languages are based on the same kind of formalisms of that first wave AI, the logic based approaches where you can reason about programs, for example. And that has a lot of the same weaknesses of the expert system kinds of AI based systems, that it's very time consuming and fragile. And a lot of programming language techniques now are being augmented with machine learning based approaches, which can you learn representations, can you learn heuristics that can make your programming language analyses go faster and be data driven instead of handcrafted. And that goes along with proof repair, program repair kinds of ideas, and the kind of work that Talia is famous for.
The contextual wave that you're talking about and this flexibility in reasoning, I suppose there's been a lot of talk about generally neuro-symbolic AI and things at this intersection that you're speaking to. And I remember Chris Manning giving a really interesting talk on this a while ago that was talking about, I don't know exactly what the terminology he used for it was, but the idea was that there's really this spectrum that on all the way on one end, you have the kind of pure connectionist program, and then on the other, you have the pure symbolic program, and there's lots of stuff in between. And I suppose that at each point along that spectrum, there's a set of trade offs you make between flexibility and guarantees. And I'm curious to what extent you and maybe people at DARPA have kind of investigated these ideas and how you think about that trade off.
Yeah, that's something that we've spent a lot of time trying to think about, and we've had a number of programs that try to explore that trade-off, from like the PAML program, which was about probabilistic programming languages, where you have a kind of a first wave representation of the program, which is a kind of a scheme program or a functional program, but then you have probabilistic weights associated with different branches of the program, through the like the neurosymbolic, the answer program, which is happening right now, which is about trying to, can we find ways of tying together a specific symbolic representation and a neural representation so that you can manipulate one or the other and update them in sync. DARPA cares a lot about that kind of connection, because trustworthy AI is something that's an extreme high priority for DARPA, to the extent to which one of the analyses that we've done as part of that analytic framework is, where should DARPA be making investments? If commercial industry is going to do something anyway, then DARPA doesn't need to make that particular investment. And we think that there's lots of commercial applications for lots of AI, but the return on investment for super high trustworthy AI is perhaps farther in the future. And so DARPA cares more about sort of jumpstarting higher trustworthy AI, because more of the military applications require super highly trustworthy AI. And so trying to jumpstart AI that is more trustworthy is a place where DARPA wants to invest. And so that combination of neural symbolic is something where we want more investment.
I want to get to your thoughts on, and perhaps we can use a bit of a history of DARPA as a segue to this, but the idea of pursuing a really long-term research program where you can see that there's probably going to be some good ROI on this in the future is just fundamentally, I think, as everybody recognizes, a really hard problem. And so I really want to know how you think about this. But to, again, segue there, let's perhaps talk a little bit about the history of DARPA, the Information Innovation Office. So could you tell me a little bit about all of that and DARPA's interest and a lot of the funding that has gone into the AI community from DARPA?
Yeah, sure. So DARPA was founded in 1957, I think, in the late 50s after or the Soviet Union launched the Sputnik satellite in order to prevent and create strategic surprise, um, basically to make sure that that didn't happen again to the U.S. and that we did that instead to adversaries. And the creation of AI as a concept happened at roughly the same time. DARPA has been investing in AI technology basically ever since then. So we got involved at the very, very beginning and have more or less invested continuously in AI, although the amount that we've invested has gone up and down over time as the promise or lack of promise has gone up and down in AI. Um, DARPA doesn't, Despite that, DARPA doesn't do long-term commitment. DARPA does funding in projects, and it's a bottom-up organization. So everybody who has decision authority at DARPA has an expiration date on their badge. So that is program managers and office directors, deputy directors, the head of the agency. So you get appointed for a 2-year term and then reappointed for a 2-year term and then maybe one more year kind of thing. And programs are created by program managers through a process of coming up with an idea for a program and then going and pitching the agency of DARPA should do this and answering what's called the Heilmeier Catechism. Basically 5 questions. What are you trying to do? And when you finish answering that question, the listener should be like, oh my God, we have to do that like now. So it has this visceral, compelling, like this is really, really important. We need to do this right away. Well, the second question is, how is it done today? And that should leave you like, okay, that's clearly not good enough. Then the next question is, what is new and why do you think it might possibly succeed? So there has to be some glimmer of confidence. Answering that question is kind of you have to thread a needle. On one side, it has to have some glimmer of possibility. And on the other side, it can't be so far along that like, well, okay, that's just going to happen. Like if DARPA does nothing, it's going to happen anyway. The glimmer of possibility is like, it can't be transporter technology from Star Trek, right? It's like obviously not possible, right? It has to be possible in some way. And then who would care is number 4, and what resources would it take is number 5. And then at the end of that time, you get the resources or you don't get the resources. And so DARPA's 60-year, 70-year commitment to AI has been a series of program managers making that case over and over and over again. That AI is worth investing in. And then that means that DARPA is constantly taking a fresh take on what should we be doing in AI. Since 2018, DARPA has invested something like, $2 billion in AI. Some of that is in foundational work in AI, things like neuro-symbolic AI, things like explainable AI, things like understanding if something is out of distribution or in distribution. Some of that is in applying AI to specific application domains. Sometimes it's both, because in applying something to a specific domain, you realize that the foundational work needs more work. Like the PAML program was an example of foundational AI that was then applied to specific problems as a way of evaluating, does this foundational work actually do what we need for national security or not? There are 6 technical offices in DARPA. I2O is focused on computer science per se, but AI is being done in all of the technical offices at DARPA.
Makes sense. And so I guess maybe just giving a bit of an overview about the nature of how research is invested in and kind of thought about at DARPA, it's interesting to sort of position that with respect to, for example, how industry thinks about and commits to research, and then how academia does on one hand. And a lot of folks I've spoken to in academia think about this real portfolio approach to research, where you make small bets in different areas, although you also recognize that maybe a particular area like language models right now, of course, is really, really important to invest into, and you pursue a number of directions related to that. Whereas in industry, you of course have things like profit metrics or making whatever lines you need to go up, or something like that. And that probably has to do with a lot of research, and maybe you get to invest in some things on the side. And with DARPA, of course, the primary mission being to create and prevent strategic surprise, right? So a lot of the work from really application oriented all the way back to the fundamentals is directed towards that goal. Is that how you describe it?
Yeah, so DARPA is about like changing the world and making it safer for the U.S. national security. Those programs, um, each one has a premise of, if this program succeeds, then we will make the world, the U.S. safer, better for national security. And the goal is, in some sense, to hit grand slam. So it's to take, a high degree of risk to change the world. So it's not about being safe. In terms of the risk, it's not about like let's hit single after single. It's about let's take that big risk. So the grand challenge, for example, like self-driving cars, right? Which is an example of an AI applied program. Like the first year of the grand challenge, none of the cars made it past well, I can't remember exactly, but very far past the finish line. Like, I don't know, 100 feet or like they didn't get it. I can't remember. Very far past the finish line. So that could be like seen as a total failure. And like, let's just crawl back into our cave and declare failure and move on to something else. But that's not what DARPA did at all. Instead, they doubled down and had the next race the year after. And the year after, like 7 of the teams made it all the way to the finish line. And what happened? How did they do that? They changed how the vision system worked. The first year, the vision system was using wave 1 AI systems. They were handcrafted rules to detect obstacles and find the road. The second year, they used statistical approaches to find the road and find the obstacle, right? That was a huge change prompted in no small part by the DARPA Grand Challenge. So that they like really pushing forward, like that kind of setting the milestone of like, let's go do this and galvanizing a whole research community to move the technology in a huge leap forward. That's kind of how DARPA measures success, like creating a massive step forward.
How do you think about the component of this? And I think maybe this will help us segue a bit into AI forward. But galvanizing the research community is a really important aspect of doing a lot of this work. I think that attracting the right talent or getting people to care about a specific set of problems enough to put their own time and maybe their students' time into it seems like a really important and possibly difficult aspect of this. I think it really depends on a lot of factors. In your experience, what sort of factors have sort of contributed, I suppose, to the difficulty or ease in doing this?
Yeah, so I think part of it is telling a good story. Part of it is picking a really interesting technical problem that people want to work on anyways. I mean, another example of a challenge, like the Grand Challenge, is the Cyber Grand Challenge. Another is AICC, which is happening right now. So AICC was announced at Black Hat in August. It's about using whatever AI kind of technology, whatever technology competitors want to be able to automatically find and fix vulnerabilities in software. So the competition, the registration opens like any day now, and the competition will happen. The semifinals are at DEF CON next year in Las Vegas, and the finals are the year after with millions of dollars in prizes for the winners. The motivation for that is like Avril Hines' testimony last February to Congress that in the event that China were to invade Taiwan, they're very likely to carry out destructive cyber attacks against U.S. civilian infrastructure in advance. We have a massive digital attack surface. A lot of that is open source software. So how could we make that attack surface less vulnerable really quickly? Well, the hypothesis is we could use AI to find and fix a lot of the low-hanging fruit really, really quickly. So that's the goal. And the basis of confidence in the Heilmeier Catechism that led to that new program was work that came out a little bit before that, which was ChatGPT out of the box was just as good as bespoke tools for finding and fixing vulnerabilities in such software. So it will be exciting to see at DEF CON how well current AI tools are at, not just current tools, but what researchers can do with the current tools to find and fix vulnerabilities. And we're partnering with the frontier language model companies to do that. So OpenAI, Anthropic, Google, and Microsoft are all making available to competitors resources on their frontier models to do that work. So that's like one of the examples of how do we motivate people, right? We're giving them access to state-of-the-art tools on a problem that's of critical importance to national security to see what they can do.
This is a very exciting direction and maybe a good place for us to start talking a little bit about AI forward. So, could you tell me a little bit about DARPA's really present recent investments in AI? I think we started to speak about them a little bit, but then in particular, the motivations for the AI Forward initiative.
Sure. So AI Forward came out of, I mentioned that right after I joined DARPA, the director of the agency asked me and my deputy to do a framework on what was going on in AI. And this was before ChatGPT came out. And part of the analysis was we really need to engage the community more broadly on what we should be doing in terms of the theory of AI, the engineering of AI, and the human AI partnership. And so out of that analytic framework grew the idea of AI Forward, which was a series of two workshops that engaged the community to come and spend 2 weeks ideating with us, um, following a structure that this company called No Innovation has used. Um, the goal was to get, so it was not workshops in the form that often takes place at conferences where it's attached to a conference and people stand up at the front of the room and give small talks about work in progress and everybody sits in the audience and listens and talks to each other and then goes away. The idea was that these were participatory workshops where people do a ton of brainstorming and they do work in the conference, in the workshop that is then the product of the workshop. So we put out a call for people to apply. The application required them to write like a paragraph of a bio of who they were and what their background was, a paragraph about what they thought the most important ideas to be considered were, and a paragraph about what they might contribute to the workshop, what they might bring to the workshop. From those and whether they wanted to do the in-person one or the online one. From those, we selected the people that we thought would contribute the most to the workshop, either in terms of their background or in terms of the idea that they had, or in terms of what they might bring to the workshop. We wanted a broad diversity of perspectives, a broad background, because we thought that just having as many different kinds of voices represented in the room would get us the best brainstorming activities, set of perspectives. And then the No Innovation people are brilliant at getting a diverse set of people to share their ideas as well as possible, using scientific literature to help do that, using things like when you're listening to somebody talk, the bit rate at which people talk is lower than our bit rate at which we can consume information, which means there's a delta where you have idle time. And that idle time is like, I'm bored, I should be doing something else. And so in that something else, you get distracted. And if that something else is more interesting than what you're listening to, then you lose the thread of what you're doing and you start paying attention to something else. And so what they do is they provide little toys so that you're like playing with a little toy or with Play-Doh. And so Play-Doh isn't interesting enough to distract you from participating in the conversation. So you keep listening to the conversation. So like at that level, the activity is engineered to get people maximally engaged. And so it starts with like massive level brainstorming, and then people vote with their feet to put similar ideas together. And then they vote with their time to which ones do they invest further in. That produced something like 15 videos and 15 white papers out of the first workshop. And then that was the one on Zoom. And then there was a bridging workshop where the people from the first workshop and the second workshop got to talk to each other. And then there was a second workshop that also produced a similar number of videos and a similar number of white papers. I started each of them with a kind of opening charge about this is what DARPA is interested in, to kind of frame the ideas. That both of those framing ones talked about how with the release of ChatGPT, it's really highlighting how we're kind of in a brave new world of AI, where it's obvious that there's all sorts of brand new capabilities that are possible because we can now communicate with computers in kind of human native forms, that's opening up all sorts of new applications with all sorts of ramifications for national security. And we should be exploring those applications, everything from being able to file routine reports, write routine reports much more quickly, to possibly being able to do multi-level security and to write intelligence reports more quickly. Of course, there's all sorts of issues with hallucination and trust, and that have to be sorted out or dealt with, or maybe discover that you can't deal with them on the one side. And then there's all sorts of new threat models that have to be dealt with too. Everything from over trusting, bias issues, fairness issues, the problems with poisoning and adversarial AI, to what I call agents run amok. So very soon we will have AI-enabled agents that are fluent, that are persuasive, that are connected to the internet, which means to a first approximation connected to everything, that can write code and that can cause that code to be executed, which means they can take actions both in the digital world but also in the physical world. How do we make sure that those agents don't cause things to happen that are really bad? How do we defend against those? Also democratizing violence, right? We can have chatbots deliver information about bioweapons, about chemical weapons, about cyber weapons that will enable people to create such things that wouldn't be able to create them anyway. You can say, like, well, you can get that information from the web now, since the reason why these agents have them is because they digested it from the web. But there's a level of friction that exists on the web that doesn't exist in chatbots. So how do we defend against them? So all of that was in the kind of framing of the charge to the AI forward participants. Anyway, I've probably gone on too long, so maybe I'll stop there and let you ask questions.
This is really great. Yeah. One thing that came up in your response that I think is gathering a lot of attention too is just the dual use nature of generative AI. And you were on a paper about this that I think was a pretty big collaboration identifying and mitigating the security risks of generative AI. And I think that's some of what you talked about here. The particular capabilities and risks also came out in that paper. And so it seems, of course, really important to DARPA that we, on the one hand, want to invest in our ability to leverage the positive capabilities and then build out defenses against some of these things like proliferation of cyber attacks and some of the other issues you mentioned. I'm curious, though, in the broader sense of this debate, we in the AI community still have this kind of fundamental tension between people who are on the very long term side about AI risk and the people who are on the short term side. And one side is saying that you are talking about science fiction, and then the other is not too happy with the first side either. I'm curious where you and maybe DARPA kind of stand on some of these issues and how you think about it.
Yeah. And I think both the short term and the long term side are really important. I think that when you start to unpack the long term side and you think about what are the um, like I listened to the Gradient podcast where Jeremy and um, Andre debated the X risk, and when you started to pin down the X risk and make it concrete, a lot of the things that you'd actually do to defend against the existential risk side are not worlds away from what you would have to do to defend against the shorter term side. So I think kind of taking the X risk threat away from the abstract and making it concrete makes it less far away from the shorter term side. And I think DARPA's worried about the entire continuum of all of the threats. Um, and I think defending against any of the threats are actually quite challenging, and that figuring out how to defend against any of them are quite difficult. I think some of the recent work on alignment, on the reinforcement learning with human feedback and the fine tuning, and how easy it is to undo the fine tuning is quite concerning, right? Like the work that showed, like for 20 cents, you could use the fine tuning API for some of the frontier models and undo the alignment work is quite concerning for the future. That originally the kind of bad behavior is sort of diffuse in the frontier model, but when you do the fine tuning to say, like, okay, this is the bad behavior I don't want you to manifest, that kind of puts a bright line around it. And then breaking that bright line is then really quite easy. And it's easy to do if you want to break it, but it's also easy to inadvertently break it if you want to, or even if you don't want to. So I think we don't have a lot of good ideas, I think, about how to make frontier models or state of the art large language models safe, even if we want to. So I think that's a place where a lot more work is necessary. And I think the fact that it's not just the frontier models that we need to worry about, but the open source versions of those frontier models, that there's a lot of work we need to do.
Yeah, this is a really important point. I think the first one you made about the fact that mitigating short term risks and mitigating long term risks, some of the technical challenges to achieving that, there's a lot of overlap there. And I think a lot of people probably think it's not totally unreasonable to be worried about some of these longer term risks. And there are probably versions of that that are just kind of way out of what makes sense to worry about, but there's also lots that do make sense. With open source AI and a lot of the concerns we have right now, for example, agents running amok, a lot of this though is also not just a technical challenge, but a challenge of how we are interacting with AI systems, putting them into our infrastructure. Jan Leica of OpenAI, I think a while back, posted something to this effect, saying that we have these models that we're not entirely sure we understand. And it doesn't seem to be a great idea to immediately start putting them into really critical business workflows or whatever other workflows that might be of value to people. And so, in thinking about that aspect of things too, a lot of what you just talked about, I think, maybe leans towards the technical side. So, I'm curious how you think about this side of deployment and human interaction as well.
Yeah, I think it's really important that when we analyze whether it's suitable, whether a certain AI system is suitable for a particular task, that combination is considered really carefully. I think, AI is not a single monolithic technology. It's a whole bunch of different kinds of technologies, and that the combination of what exactly am I talking about with respect to the AI technology and what context am I considering putting it into and for what purpose, and evaluate that combination. That it's something that requires nuance, and it's something that requires judgment and technical skill, all to be considered at once. I don't think there is a single one size fits all answer that can be done um, a priori for all time, all at once. I mean, I think we seem to be living in an age that doesn't like nuance, and I think that this is a question that requires nuance.
That's a fair point. Let's maybe return back to some of the key themes of AI forward. And so maybe we can touch on some of the particular outcomes that came out of the workshops this year and what you're paying the most attention to.
Sure. So, not surprisingly, one of the key themes is understanding the partnership between AI and human systems. Another theme that came up quite a lot was understanding the threat potential of large language models or frontier models in general. Another key theme that came up was evaluation. How do we understand and how do we evaluate frontier models, which I think is a really interesting question that I think a lot of people would like to know a better answer to than what we're currently doing. Um, Metacognition was another theme, and then accelerating science. Those were kind of the five big buckets that ideas fell into. As I said, there were something like 30 white papers that came out. We gave those papers to all the PMs in the agency, but specifically to the program managers in my office, and asked them to pitch AIEs, which are a kind of small program, an AI exploration. And out of that, we picked three to post. We had promised people that we would announce two new artificial intelligence initiatives, explorations. Two of them are currently on the street. One of them is called Found Sci. So this is about creating a tool to help scientists. So to help to do science, like to see if we could create an AI agent that would be able to do science, something along the lines of uh, AlphaFold. Obviously, that's grandiose. DARPA kind of does grandiose. That's our charter. Um, so AlphaFold had a huge amount of hard-coded science in it. So the idea of this AIE is: could you read the an AI agent read the literature and figure out for itself what it needed to learn and propose scientific hypotheses and be able to accelerate the pace of science on its own in the domain that the people who propose come up with on its own. So this is an exploration in the area of creating AI agents that could themselves accelerate science in particular domains. So that was one in the area of using. I talked before about how the framing was using the new capabilities to accelerate things, and the other was defending things. The second AIE is about defending things, and this is called FACT, and that stands for friction for accountability in conversational transactions. And this is about defending things. And it comes out of the observation, and it's in the human AI teaming general theme. And it comes out of the observation that people tend to overtrust computer systems in general and large language models in particular, partly just because we tend to overtrust computer systems in general, but also because large language models tend to talk in this sort of very confident, almost professorial tone. And the idea is, can we create a kind of third conversational partner that participates in our conversations with chatbots and is sort of the skeptic that's like, why do you think it thinks that? Maybe you should question that, and kind of just adds friction into the conversation that causes us to like, wait a minute, why does it say that? Or should I trust that? Or maybe I should go check that. To give us to help us develop an appropriate level of trust in what the chatbot is thinking.
That second one is really interesting and is something that's come up in a few of my other conversations as well. I know June Park did work a while ago on slow algorithms. Vera Liao has done some work on seamful interactions with AI systems. And I think these are kind of speaking to very similar ideas of, again, we tend to overtrust things, but if we build in some amount of friction, we can get people to be a little bit more reflective. And in the case of what you're talking about, a third conversational partner, we can really explicitly prompt what are the sorts of reflections that might be useful in this interaction, where might it be best to actually investigate a little bit more and think about this a little bit more carefully before we actually act on things that we're being told. I think that this is, again, a really kind of key research area. But then there's also the matter of incentives and people sort of being willing to actually introduce these sorts of systems into their workflows. I think that one thing, I can't remember if it was noted in this specific proposal, but one thing that's often noted in conversations like these is for businesses at least, there's a strong incentive to make interactions as seamless as possible. And so even if you solve the technical challenge, there is that fundamental aspect of convincing people. And I'm curious how you think about that aspect of things.
Yeah. So in fact, that exact observation was one of the motivations for why DARPA would fund this work, because it felt like industry might be less willing to fund this work because industry is motivated in frictionless experiences. Yeah, I think that people are not so inclined to be gullible. So you could imagine that people might be interested in adding this to their workflow, even if so like the customer might ask for this. Or in fact, it is part of the executive order, right? It might be something that governments or regulators might say, like, you need to add this kind of capability as a way of increasing the overall trust in the system. Or in fact, the companies might be willing to add this as part of an overall increase in trust in the industry. Yeah, I don't know what like DARPA doesn't do policy, right? DARPA does technology, and adding sort of tools to the quiver of the policymakers quiver, I guess. Arrows to the quiver of the policymakers, giving them options that they don't already have. If we don't explore whether the technology is possible and have it as an option, then they can't introduce it.
Yeah, this is maybe a question just coming from a lack of background about the interactions between DARPA and maybe other government agencies. But I guess what you described is kind of this one way we are building out and funding lots of technology, and then the policymakers have a better sense of what's available, or as you said, more tools at their disposal in order to formulate policy proposals. Is that mainly a single direction, or are there, again, DARPA not doing policy, but is there sort of any kind of influence in the other direction in terms of policy or concerns from policymakers driving things that DARPA might ultimately be interested in?
Right. So DARPA talks to a lot of people. We try to stay informed, and we try to help other people stay informed. I mentioned at the beginning that DARPA doesn't do commitment, right? So we try not to be tied down. We try to be very flexible so that we can move at speed, to take technical risk off the table, to provide technical options for other people. So we try to stay very true to that, not being committed to other organizations. But we do try to be very informed. So we do have lots of conversations with policymakers, in the executive branch and in the legislative branch, so that we are aware of what their concerns are and what we might be able to provide to them.
I think maybe to begin bringing things to a little bit of a close here, we've talked about these two AI exploration efforts and some of the key themes coming out of AI Forward. Is there anything else that maybe we haven't touched on that's sort of on your radar as far as future directions that DARPA might want to fund, might want to explore?
Right. A couple things I haven't talked about that might be worth exploring is, the manipulated media. The Semaphore program is something that DARPA has been working on quite a long time, detecting. So one of the things that the Semaphore program has been doing, for example, is building up defensive models for people of interest. So when people talk, like when the Zelensky video saying, the fake video of Zelensky saying that Ukraine should surrender, that's the kind of thing that the Semaphore program has a defensive model for. So famous people, like anybody, when they talk, they have idiosyncratic facial movements, like the side of my lip might move up when I say the word hello, for example. And the researchers on the Semaphore program have developed models that you can have a certain amount of video of that person talking, that they can then build models of that person, that when you then have a purported video, you can you can apply the model to the video and see whether it's that person or not. And not only can you then just label that that was fake or that that was true, you can highlight, like, here's where the person always lifts their left eyebrow when they say this word, and here how they're not doing that. So a person can see for themselves whether the video is manipulated or not. The Semaphore program has been developing that kind of technology for video, for audio, for still pictures, et cetera, that a layperson can look at the outputs and see for themselves very quickly if something's been manipulated or not. So be able to build trust in video. And they've been doing that for like 8 years. So DARPA was well ahead of the curve on manipulated media, working with partners like NVIDIA on, like, when NVIDIA generated the StyleGAN 3 image generator for portraits, they released a detector at the same time that was developed as part of the Semaphore program. So kind of developing a best practice of when you release a detector, when you release a generator, you can release the detector at the same time. Something else that DARPA has been quite interested in is adversarial AI. The GUARD program has been working on tools to defend against or to explore adversarial AI. So the universal prompt hack that trained on open source models, but then were able to jailbreak most of the frontier models, that was done under the GUARD program. The one that, like, you could generate jailbreak, it could generate what looked like gibberish, but that you could attach it as a suffix to any prompt, and that it had like 87% success against GPT 3.5 and 50% against GPT 4. That was funded by the GUARD program. I think that was really one of the things that was really interesting about that was that it worked on almost all of the frontier models, but like not Claude out of Anthropic. Like, what was different about Claude? So like, anyway, DARPA is doing a lot of really interesting work on a lot of different programs. But that DARPA, as I mentioned before, is a bottom-up organization where ideas for programs come from program managers. Program managers have expiration dates on their badges. They tend to be here for 3 to 4 years. Program managers come from academia, they come from industry, they come from nonprofits, they come from the military. But that expiration date means that we are always hiring. So, like many of your listeners, they come from AI from all over the place. If any of your listeners are interested in possibly coming and being a DARPA program manager, I would be more than interested in talking to such people.
Yeah, I'll make sure we include a little bit of a note in our show notes for this. And for people who might be interested in some of this work as well, besides becoming a program manager, are there any other ways folks can get involved, stay up to date on what DARPA is doing?
Yeah, so I2O has a mailing list where we publish new programs whenever they come out. We also publish whenever there's a new program manager that is hired. So that's joining that mailing list, which we can also include in the show notes, is a really good way of staying up to date. Also, part of my job is staying at the frontier of what's going on in AI, which you do the same thing, right? So it's practically a full-time job. So part of how I do that is I talk to lots of people, and one of the things I always tell them is if something is happening that you think I should know about, please send me email. So there's a way to reach me from the I2O website. So like if one of your listeners is aware of something like, oh my goodness, I2O or DARPA should know about this thing that just happened, please don't hesitate to reach out and help us, because it's critically important that the U.S. stay at the forefront and keep our strategic lead of what's happening in AI, because the capabilities that AI is bringing is of critical importance to national security. It would be really bad if we lose our edge, because it's such an important technology with such important consequences for national security.
Agreed. And this has been a really interesting and insightful conversation. So, Kathleen, I want to say thank you for taking the time to speak with me today and for sharing all of this.
My pleasure. Thank you for having me. It's been a pleasure.
That is all we have for today's episode. Thank you so much for listening. Again, if you enjoy what we're doing, there are multiple ways to support us. If you like the podcast, you should make sure that you're subscribed on whatever podcast player you're using to listen to this. And finally, you can find our other articles and newsletters by subscribing to us on Substack and at thegradient.pub.